Hello and welcome to this lesson about human response to thermal environment. In this lesson, we will talk about heat gain and loss mechanism, metabolic rate and its impact on thermal comfort, and clothing insulation and its role in thermal comfort. The learning objectives for this lesson are to describe the human body's thermal regulation mechanism, including heat gain, heat loss, and the role of sweating and shivering, to explain the concept of metabolic rate and its impact on thermal comfort, including how different activities influence heat production, and to understand the role of clothing insulation in maintaining thermal comfort and how it affects the heat gain and losses. So let's start with a question. Why do some people prefer warmer temperatures while others prefer cooler temperatures? So you maybe have experienced this in a room, that in the same room some people feel cold and another feel warm. So what we are going to learn in this lesson is what is the reason of this difference between two persons. This will have to be with the heat gain and loss mechanism of the human body. So talking about thermal comfort, humans are most comfortable when their bodies maintain a neutral thermal state. So this means that they are neither heating up or cooling down. And there is also energy balance. So the human body strives to maintain a balance between heat gain and heat loss. One of these mechanisms that we have, and the most important for thermal comfort, is the metabolic heat generation. This is the body that generates heat through metabolic processes like digestion, muscle activity, or respiration. So the heat exchange with the environment is done through the common heat transfer mechanism: conduction, so through direct contact with the surfaces; convection, there is a heat transfer through the movement of the indoor air; radiation, there is the heat transfer through electromagnetic waves that we have with the interior surfaces; and evaporation, through the heat loss that we produce because of evaporation of sweat. So in this diagram, we see that losses or gains of heat and moisture transfer through respiration, and then we see the heat and moisture transfer through clothing and from the skin. And then we also do a mechanical work, and as we talked before, we produce heat in the form of our metabolism rate. So in this equation of this energy balance equation, this part here is the energy that we are storing in our bodies. And then the other mechanism that our body has to keep the neutral state is sweating and shivering. So we all have experienced sweating. That is when the body's core temperature rises. Our sweat glands release this moisture onto the skin, which evaporates, and this evaporation cools the body. And then we have shivering, that is the primary mechanism for warming. So when the body core temperature drops, involuntary muscle contraction generates heat. Going to the second part of this lesson, we have the metabolic rate and its impact on thermal comfort. So we have been talking about metabolic rate, that is this rate at which the body uses energy measured in metabolic units, the METs. So 1 MET is equivalent to the metabolic rate of a person at rest, that is approximately 105 watts. So what is the impact of thermal comfort is that with increased metabolic rate, so for example during physical activity, we generate more heat. So this means that we require increased heat loss to maintain our thermal comfort. And the opposite happens with decrease of metabolic rate. So during rest, the body generates less heat, and then this less heat loss is required to the environment. So the metabolic rate and its impact on thermal comfort, we see here that different activities have different levels of metabolic rate. So in the units of METs, we see how resting is the equivalent of 1 MET. And then the harder the activity, like moderate bench work, has higher METS units. This is divided in latent and sensible heat, and then here is the total in watts. So we can see here that in a same room, we can, for example, in an office, we can have two people having doing different activities, and then this is going to lead that each of them has different metabolic rate. So talking about the design of air conditioning systems, we need a way to find and to give satisfaction with the thermal environment to all the people. So, but not only metabolism, it can be different. We can also talk about clothing and the clothing insulation and its role on thermal comfort. So this, our clothes acts as a barrier affecting heat exchange between the body and the environment. So we have that 90% of the metabolic rate is transferred to the environment through clothing layer and exposed skin. And this clothing insulation is measuring cloth value that is equal approximately to 0.155 units of thermal resistance. Then we see that the heavier the clothing, the more is the resistance, the cloth value is higher. And but then once again, inside an office, we can have different people dressing in different ways. So now we have different metabolic rate and different clothing that is going to affect the energy, the heat transfer between the body and the indoor environment. So we can see like that increase insulation in our clothes, so reduce the heat loss in cold environments, but also reduce the heat gain in a warm environment. This means when heating is on. And then decrease insulation. So when increase heat loss in cold environment, it will increase heat loss in cold environments and increase the heat gain in warm environments. So from this lesson, we have some key takeaways. For the human body as a thermal system, no. The human body functions as a complex thermal system balancing heat gain and heat loss to maintain a stable core temperature. Remember that we like to feel at a neutral state. The metabolic rate and thermal comfort. So the physical activity significantly impacts metabolic heat production, influencing the body's thermal balance and comfort. And the clothing insulation and thermal comfort. Clothing plays a crucial role in regulating body temperature by influencing heat exchange with the environment. So thank you for listening to this lesson. I invite you to continue learning with other material in adaptive thermal comfort. There is a way to measure thermal comfort when people can control the indoor environment. Thermal comfort in special environments like hospitals, and energy efficient strategies for achieving thermal comfort. Thank you.